Good evening. So, my name is David Sankel. I'm from Bloomberg, and the topic of this talk is, so you inherited a large code base. So let's talk about the problem. So this is you. You've read all the books. You are a master of writing the code. You can make a new API, you can make a beautiful API, and it is sweet. You go to the conferences, watch all the best talks. Shameless plug. Basically, when you want to write some code, it's like an open field. You start a text editor, it's completely empty, and you build a beautiful API, right? Something, template metaprogramming, really good STL style code, whatever it is. You've got this thing down, right? You're one of the top 5%. The 5% that can write a really high quality API. And it is sweet. I don't know how many of you guys have written an API and watched that sucker take off and get a ton of users. It is awesome, super fun. So you're a code ninja. And you've got a new assignment. And this is to make an existing code base into a best-in-class code base. And this code base is big. This is a different problem, right? All that stuff that we learned about how to make a nice API from scratch, most of it doesn't really apply. So this is not a talk about how to create high-quality, maintainable software from scratch. No. There's another talk I gave about building software capital that's about that, but that's not what this talk's about. This is actually a much harder problem. So let's look at some characteristics of large projects and see if we can get some hints as to what we can do about it. So large projects are usually successful. There's a reason that they're large. Someone invested a ton of money into it, and is successful. Widely in use, ton of users, many past contributors. Usually one person doesn't make a really large code base. And there's going to be varying degrees of quality and maintainability. Now, can someone raise your hand if you've worked with a project that's measured in the millions of lines of code and it's been uniform, really amazing quality? One? All right. I've seen that code base. There are some amazing qualities. Now, frequently there's mixed styles in the code. You know, one person isn't doing the same style everywhere. There's hidden use cases. This is real pain in the neck. There's some people using your code in ways which you do not know how, and it is critical that that kind of functionality, which you don't know about, already exists in your code base, stays working that way. Because if you change it, it'll break something. Hidden use cases, they're a pain. And partial refactors. This one's ugly. How many of you have worked with a code base where someone has started the process of changing something and it never got complete? It's like everybody, right? This is really common. And if you have a large code base, this has happened multiple times over a large period of time, 10, 20 years, and there's a lot of that stuff in there. So these are the characteristics of large projects. Now, what are the unique problems that a large code base faces? Those were the characteristics. What are the unique problems? Let's talk about toilets. Toilets are awesome devices when you think about it. I would venture to guess that every single person in this room has used this device at least once in the past 24 hours. Or at least the last 48 hours, I hope. But anyway, there was a new innovation to these devices that came out in the past, 10, 20 years. And it's pretty cool. What you can do is when you close the toilet seat when you're done, instead of having to gently close it, you give it a little tap and it just goes tss, closes on its own. You've seen these things, right? So nice. You're done with the bathroom, you just tap that thing and you're out of there. Well, wash your hands, right? And then you're out of there. Well, if you get one of these things installed in your house, it's wonderful. You know, you just do that. And then the first thing that happens when you go to someone else's house, bam, right? It's like an earthquake when these things shut. You may not shatter the thing, but it's going to be seriously dented, okay? And this leads to the first major problem with large code bases. And that is assumption is the mother of all mess-ups. You get into a large code base and you start making assumptions based on what you've seen previously. And those assumptions don't work and bad things happen. You cannot make assumptions with a large code base. What are some dangerous assumptions that folks can make? You assume that tests cover all the cases, okay? Can't assume that most of the time. You assume that the documentation is accurate. Most of the time you would hope. You assume that there are certain use cases. You assume that some kind of migration, what kind of cost of migration would be to something new, and you assume some kind of semantics. These are just dangerous assumptions to make. And when you make an assumption and there's a mistake, with a large code base, the mistake has big ramifications. If you've only got one user and you make a mistake, well, the user tells you off or whatever, and you say, Sally, I'm sorry, and you do something new, and it's fine. But if you got 1,000 users, or even if you have a few users, but it's extremely critical, the ramifications are big. Because you don't gain wide adoption on a code base unless it's sat over a period of time and it's grown for a certain amount of time. So mistakes are a big deal. That means no cowboys. Cowboys, absolutely not. Do not let cowboys into your large code base because they will screw something up. But just to be clear, ninjas are fine. So another common mistake with code bases. So let's say you're working on your house, maybe you're installing a lamp in the ceiling or something like that, and then you go to the garage because you need to get a screwdriver. And you see this, and you think, hey, maybe I should clean this up. And then you end up spending hours and hours and hours cleaning up the garage, and you never actually get to the point to where you install the new light fixture in the ceiling. So this happens in a code base the exact same way. Now let's say you got a bunch of components, and that one in the yellow there, that's the golden one. That's the one you need to make a modification for because there's some kind of core business value or whatever. And you're modifying this component, and you see all the things that it depend on, and you think, boy, there's a lot of cleanup that can be done around here. And maybe you want to do that. Of course, you got a huge code base, and it's been sitting there for years. Of course, technology's progressed. Of course, you have progressed, and you're going to see a ton of things that can be improved. But it's easy to get distracted and start working on the things that you see, right? Is that really the highest priority thing? So distractions. This is another really key, common pitfall with large code bases. You can end up doing a refactor that has a questionable benefit-cost ratio. You might do a drive-by fix that has huge implications without realizing it. Something to keep in mind. What is this thing? I don't know, but it looks cool. It is shiny, and I think I want some of that for my project. Shiny new things. This is a word I want you all to insert into your vocabulary. Neophilia. It's a real word. An attraction for things that are new. Love of the novel. We all have it, right? As human beings, new things are new and they're cool. However, when you're trying to prioritize what you're going to do with your large-scale project, neophilia should be accounted for in a negative way. It should not come into the decision process as to what you're going to do with your large project, what you're going to change to. But you got to recognize that you got it. So neophilia, maybe there's competing technologies. Someone says, hey, this thing's new. It came out from this fancy company and we'd like to adopt this everywhere instead of the other thing. Okay, that happens all the time. Maybe a new fancy build system, new tools, coding styles and standards, idioms and techniques. Now I'm not saying that something is bad because it's new. That would be neophobia. What I'm saying is that you have to be aware of a natural tendency to want things that are new just because they're new. You have to weigh the factors pro and con for adopting a new technology, especially with a large code base, because adopting anything costs a lot. All right, final thing, baseball. How many of you have played baseball? Okay, many of you, maybe it's not so common outside the United States, but it's a really cool game. And when you play baseball or softball and you get a coach They always tell you something when you do the bat, because when you swing the bat, what people have a tendency to do is they swing it almost all the way, and then they ting the ball, and it doesn't go as far as you want. So what does the coach always tell you to do? Follow through, right? All the way through. Finish the thing that you started. And lack of follow-through is a big deal in large code bases. So let's do a fictional story of follow-through. In 2000, a developer decides to switch test frameworks. Fine. 2002, the transition is 90% done. That's awesome, 90% done. But priorities are shifted. The developer goes on to do something else. 2004, a different developer decides to switch test frameworks. And in 2006, the transition of the 2002 style tests is 90% done. But priorities shift. Then in 2008, a developer decides to switch test frameworks. You get the idea. If you don't follow through, how many replicated technologies are you going to have in your code base? It'll be a function of time. And this is a really big deal. You've got to be able to follow through or give up. So, follow through. Inability to follow through leads to multiple redundant technologies that increase with number over time. And what you end up with is something like a Frankenstein's monster. But even worse than Frankenstein's monster, because it'd be like a Frankenstein's monster where one arm is like from one person and there was another person, they don't even like line up right. Bad. And a partial change is destruction of value. And this is something so key to keep in mind. It's just like if you have a kitchen, you're remodeling it, you got to take out stuff from the old kitchen and you can't use it for a while, right? It's destruction of value. You don't get to a higher value place until the new kitchen is put in and everything is all functional. So anytime you do a code base and you take something which, if you do some kind of code change with your code base and you take something and you're going to replace it with something else, that intermediate stage is a destruction of value. And it's important to recognize and keep in mind that that's exactly what it is. So here we got the 4 pitfalls of large projects: assumption, distraction, neophilia, and lack of follow-through. All right, enough about the problem. How do we deal with this? So day 1, establish your ground rules. New code must be software capital. Unit tests, peer review, contracts, documentation, etc. That has to be the rule. And I'm not going to go into the detail of what software capital looks like. There's another talk about that, and many other talks at the conference. This is something we already know how to do. Develop really high quality stuff from the get-go. Make a rule. Tech debt may not be introduced into the code base. It's very easy. If in a given sprint, you make the decision that tech debt cannot be introduced in the code base, you look at the end of the sprint. Is there tech debt being introduced? If yes, then revert it. Do not allow it to happen. And total quality. Total quality, now this is somewhat controversial, but what it means is the same amount of rigor that you apply to your most commonly used API in terms of unit tests and code reviews and whatever applies to the most minimal, tiny little thing that doesn't matter at this point. And the reason why is because you don't know what code you're writing today is going to be extremely reused in the future. You just don't know. So it's better not to take the risk and write it all to the same quality. I even have unit tests for some of my build code. That's what I mean by that. And then the second thing to do is to create an infrastructure team. If you've got a large code base, which is measured in the millions of lines of code, you need to have somebody or some group responsible for that entire code base. And establish continuous integration and coding standards and tools and so on and so forth. And the thing to keep in mind is that your general approach, whatever you decide is your main operation, is going to define what the code's going to look like in the next 5 years. If you allow a little bit of tech debt in every once in a while, that's going to add up over a period of time, and you're going to get a bunch of tech debt at the end of it. Are you destroying value, or are you creating value? These are things to keep in mind. It's like the butterfly effect. A little decision that you make, that you do habitually, is going to have a big ballooning effect in terms of what the code is going to look like years down the line. So keep all that in mind. Automation. Automation is essential. Day 1.5, clang-format your code base. I like this because it's a good early success. This is an operation you can apply to your entire code base. It's low risk. I've never heard of a clang format which actually changes semantics. Now, if you're putting stuff in your comments or something like that and it has semantic meaning, Please stop doing that, but don't run clang-format on your code base. Like, fix that first. And this sets the stage for future refactors, because if you're going to be making wide changes to your code base, you need to have some kind of automated formatting, otherwise the code's going to end up looking really weird. So I want to show you what it looks like to do an automated code change to your code base. There's been a lot of talk about using Clang to do automated refactors, but I want to show you how simple it is. It really is not hard. What we're doing here is we're using the Python framework that's distributed with Clang. You just install Clang, and then you start Python, and you can import these modules. And here's an example where we have a find child function which is being defined. It takes in a parent, which is a node in your parse tree. It takes in a kind, which would be like a function declaration or a switch statement or something along those lines, and a spelling, which is a string. And what it does is it gets the children of the node. If the kind is the node's kind and the spelling is the node's spelling, it returns the node. Pretty basic stuff, right? This is not hard to implement. Let's say you want to use this function we just generated to find the abstract syntax tree node for main. This one takes in a translation unit. Okay, this is something that Clang will provide us. And we call find child on the cursor associated with the translation unit. This is the top level cursor in your translation unit. The kind is a function declaration, main is a function declaration, and the spelling of that function is main. That's it. You call that, and now you have a cursor to main. If you want to take a cursor and you want to dump its output, here's a way to do that. You just get the corresponding tokens and print it. We've got some code that'll, when it does a refactor, it'll just dump the tokens, one per line. It's ugly as can be, right? It's just a huge set of tokens. Run clang-format on that thing, boom, you're as good as new. This stuff is easy. And we've been able to do refactoring of tests, like switch complete test frameworks by writing one of these scripts. The script itself was, I think it was only like 500 lines. You just got to try doing this the first time. Do it the first time, get the expertise, and then you'll get more comfortable with what kind of changes you can apply to your large code base. Really important. And this here is just the boilerplate you need to do to put it all together. How do you get a translation unit? So you can pass in a compilation database directory. If you're using CMake, CMake is going to generate a compilation database. You just point it to your CMake directory. What this compilation database does is it provides you with the command line arguments that you would use to compile something for every single piece of source code that's being built there. If you don't want to use the compilation database, you can just specify what the command line should be for Clang to interpret this file. So in this example anyway, you're looking at the compilation database, you're getting the commands and the arguments, and you call parse. You get a translation unit, and you can get diagnostics. These are like the warnings or the errors or whatever, and you can print those out and return the translation unit. That's it. This ties it all together. It doesn't have to be a big, scary thing. Now, I know that there's also a C++ level API for Clang, and it has some more powerful things, but that requires compiling Clang or using a Clang library and getting all that whole build set up. I think the Python's a lot easier to get started with anyway. Even if it doesn't have all the same features, it has enough. So, general infrastructure automation. Here are some things to automate. So refactors, these are what we just talked about using Clang. Library updates. If you change your coding standards, you want to be able to apply the change to your entire code base. And you can do that with these kinds of automation. Coding conventions, documentation. If you have some boilerplate that you have to do for your documentation in your large-scale code base, you should automate that. That way you get it right, and it's not such a burden for developers to work with. One of the things I've seen is that if you put a lot of constraints on what it takes to make a new file, then people will have a tendency to be lazy and want to add stuff to the old file. And now, of course, you could just say, well, they should not be lazy and they should just do it. But I would like to make it so it's easier for them to make a new file. Like lower the burden for writing really good quality code. Any kind of manual developer tasks that people are doing, try to automate that thing. And indexing the code base. So Kythe is a really promising technology. You can index your entire code base using the Clang parser and that kind of functionality. And you can ask, who's calling this function? And get an answer to that question. That's very useful when you're trying to decide how you're going to refactor a large-scale code base, because you don't generally have information like that at your fingertips. Organization. So this is my daughter Carmen. She just recently turned this many years. And what she's standing next to is a pile of books. Does anyone want to throw out a guess as to how many lines of code that pile of books is? I guess we don't think about this enough, right? That's 1 million lines of code. Right there. About as tall as my daughter. And that's a lot of information. Can any of you retain that much information in your head at a time? Especially technical information about code? Of course not. You can't do that. To be an expert in that amount of information, you're only going to be an expert in a slice of it. So when you're working with a large-scale code base, you can't be expected to know everything. That makes it all the more important to be able to organize your code, to be able to think about it from a higher level perspective, like indexing. So reasoning about your code base and navigating your code base. If you're using an editor that doesn't allow you to take a function that's being used and go to its declaration, don't talk to me. You have to be able to have the basic tools on how to navigate your code base. Now, if you're using Vim, you're using the right editor. So, package level and group level documentation. I know it's like pulling teeth sometimes to try to get someone to document a function. You need to pull those teeth even harder. That class needs to be documented. That component needs to be documented. That library needs to be documented. And if you have collections of libraries like we do at Bloomberg called package groups, that thing needs to be documented too. Otherwise, it's going to be hopeless trying to figure out what do you have in your code base. So this is really important. And the final thing here is levelization. This is a way for you to understand the dependencies of your code base. So this is a levelization example coming from the BDE libraries. I'll explain what this means. So all of these things are part of a package group called BSL. That's Bloomberg's implementation of the standard library. And so each of these packages are in this package group. And at the very bottom level, level 1, BSL FWD and BSLS, what these packages do is they don't depend on anything else in this package group. They're at the very lowest level, and they don't depend on each other. At the next level, BSL SCM, this only depends on the stuff beneath it, and so on and so forth. So if you're looking at a code base and you have a levelization like this, and you just say, okay, I really want to understand this thing, what is the reading order? Well, you start at the lowest level, read the documentation for BSLS and FWD, then you can look at the stuff at level 2, level 3, level 4, and so on and so forth. You could even have documentation at the group level which says, you know what, you really, if you're looking to use this thing as an API, you don't have to look at level 5 and below. Just look at the stuff at 6 and above. And those are good places to start. This kind of documentation, this kind of indexing of your code base, it needs to start somewhere. So I highly recommend if you're working with a large-scale code base that doesn't have this kind of information to add it. And then you'll be able to work with it a little bit better. And by the way, Beazle. We have at Bloomberg an open source thing like a Beazle that's called BDE. And if you want to see what really high standards look like, check out BDE. And if you want to see, never mind, just compare it to a Beazle, and you'll see what I mean. Mnemonic methods. These are really fun. So there's a story, an ancient story about a tower called Babel. And these people tried to make this tower that goes all the way to the heavens. And God got upset because they thought they were so cool to build something like this. And he made them all speak different languages. They couldn't speak to each other, and the tower eventually fell apart and the people dispersed. And that's where we got language. That's how the story goes anyway. Well, these people did not have mnemonic methods. If they had mnemonic methods, this would not have happened. So I'm going to explain what mnemonic methods are. Here's an example of a factual statement about a code base. I'll read it quickly. Process control response passes the request to gateway manager process control response, which then calls add active route. If deauthorization SP doesn't have the request, it is added to depending routes and controls return to process control response. Process control response then checks pending routes, and if necessary, updates deauthorization SP once this is done. Process control response and thus add active routes called again, but this time depending routes is set and the task is accomplished. Got it? You can't retain this stuff in your head. My head just wants to push it out as soon as it comes in. So mnemonic methods gives us a way to be able to comprehend this stuff. So I'm going to tell you a story about a king. There's a king, and he needs to get some kind of errand done. So he goes to the butler, and he says, "Butler, I've got to do an errand." Butler goes to the manservant, says, "Manservant, go do the errand." Manservant goes to the garage, and alas, the car isn't there. So the manservant goes back to the butler, and he tells the butler what's going on. And then the butler goes to the bathroom, and he writes a note on the wall saying the van isn't in the garage. Then the butler goes and sits down. The king saw the butler sit down, so he went to the bathroom and read the note on the wall and saw that the van wasn't in the garage. So he got the van to go in the garage. Then the king went back, sat down, and told the butler, "Go do the errand." The butler then told the manservant to go do the errand, and the manservant saw that the car was in the garage and did the errand. Got it? So who wrote the note on the wall in the bathroom? The butler, right? I mean, it's a crazy, ridiculous story, but we all get it. You only hear it once, and you remember it. This is the way our brains work, right? We're very good at understanding stories, and we're very good at retaining stories that have crazy information. And let me tell you, it's hilarious watching people walk by when you're having a heated discussion about who's going to put the writing on the note in the bathroom. But anyway, this allows us to be able to use our human brains to be able to comprehend things which are technically really complex. Mnemonic methods. So, mnemonic methods facilitate comprehension and communication of complex interaction for humans. Works very good for humans. The stranger the story, the easier it is to be retained, and it must have a concrete mapping to code to be useful. So for example, the king, the manservant, the butler, they all correspond to very specific pieces of code in that statement that I showed you earlier. And then you can actually have a decent discussion about these things. Find bugs this way, actually. So another important thing to do is to gauge difficulty. You have to realize that when you're working with a large code base and you need to make some kind of change, that there are easy problems and there are hard problems. What are the characteristics of the easy problems? These are the ones that we can solve. Strictly additive, if you just need to add a new class, inherit from something else and specialize it, easy. Pure functions. Pure functions don't deal with global state, no side effects. Those are easy to work with. Few interactions, simple semantics, small components, and uniform dependence. What I mean by that is everybody who's using your code is using it in the same way. That's great, because that means if you need to make some kind of change in interface, it's very easy for you to go and refactor all those users of it. Hard problems involve reworking existing components, things that have globals and side effects, many interactions, complex semantics, and by many interactions, I mean interactions between components. Like you can't really understand this one without seeing how it interacts with this one, and there's a big discussion about how they all talk with each other. Large components are hard to work with, and diverse dependence. This is the big deal. If you have a piece of code and it's being used in many different ways, it's much harder to be able to refactor all your users to use a new interface. So just keep it in mind, there's a spectrum of challenges. And when someone proposes some kind of change to the code base, you see what kind of characteristics does it have. Because the stuff on the far hard side, we don't know how to do these things. And the stuff on the easy side, we know for sure. And there's all this range in between, something to keep in mind. Now, measure instead of assuming. Assumption is the mother of all mess-ups. So we got to measure as a way to mitigate that problem. What are the clients doing with your code? Don't guess. Look. Measure. Figure it out. You've got the tools to do this. Do it. Be informed. What's the impact of the code change going to be? This is something you can measure. Instrument the code. Like a lot of times you can just figure out what the clients are doing by looking at how they're calling your function, but you don't know how often they're calling it. You don't know what kind of constraints they have in terms of like what's the load on that particular function. You can instrument your code to answer these kinds of questions, and then you can make more informed decisions. And absolutely choose your priorities wisely. Gauge the difficulty of the problem, and start with easy problems to build confidence. If you're going to start with some major refactoring thing, don't do that. Start with something easy. Start with something to build your ability to be able to make changes to a large code base in a successful way. What is a not success is starting something and stopping halfway through and never restarting it again. And of course, you got to consider the business value before embarking on a project. Let's say there's some newfangled library that everybody wants to use. What's the cost of that going to be to switch to that library? And what business value does it create? These are questions to be answered. And of course, invest in the future. Anything that you can do which is going to make day-to-day life easier on a project, just do it. Especially for a large-scale project, if it's lasted this long, it'll probably last twice as long. And I will say, this is really important, it's okay to give up and undo a started attempt. If you start to do something, and you realize at some point it's going to take longer than you thought, or it's more complex than you thought, it's okay to give up, but then undo what you did. And it's okay to do that even if the cost of doing so is significant. It's worth it in the scheme of things, because having a halfway done thing causes an awful lot more damage than starting something and then going back to, not being able to finish it and then going back to the starting point. Migration paths. So for people on my team, they see me ask this question all the time, anytime something is suggested. What's the migration path for that? We tend not to ask these questions, right? Because we're developing new APIs from scratch. There's no migration path. You build a new thing and then all the users come and switch to it, right? But in reality, with a large project, you have to have migration paths. And you got to be able to answer that question. So most all efforts have flawed migration paths. Most of the time, nobody really thought about it. And when you're doing something that's nice for a migration path, a nice characteristic to have is to have migrate a small change everywhere. So if you have some grand vision of where you want to end up, if you can start with a small change, migrate all your clients and everything to use it, make another small change, migrate all your clients to use it, that process seems to have a lot more success. Because if you have to stop somewhere in the middle, you've already added value to that point. Whereas if you build the new thing in isolation, and then you slowly have all the clients adapt to this really strangely new thing, man, that'll fail. Or it fails very frequently. I haven't seen much successes with that kind of migration plan. And one thing to keep in mind is that your code transformations, when you write these Clang refactoring tools that are specific to your project, you have to prove that the semantics of the old meet the semantics of the new. Because you can't really depend on everybody running all unit tests to make sure there's not a bug in your code. You can assume that they're going to test to make sure there's a bug in their code. But maybe don't even assume that. But you can mathematically prove your code transformations, and if you do that, you're good to go. And don't be afraid. I did use the word math there. Reasoning about code is something we do all the time. You can take a look at a piece of code transformation and you can show that this is indeed equivalent to the original. It's not that big of a deal. And of course, consider timeline and changing business priorities. Something that management says is a really big deal right now. Maybe there's a 2-year project. This is really big. Are you committed to this? Oh yeah, we're committed. When you get 1.5 years down the line, all of a sudden there's a new big deal. That's a risk. And if you're 1.5 years down a partial refactor, you got a problem. You were probably better off with the original and not having started it in the first place. So this is something to keep in mind when you're prioritizing, that management things will change. So prefer things that you can do on a smaller timetable. And that'll minimize the risk to a certain extent. And here's some beautiful words. I don't know how to make a migration path for that yet. I like this because this introduces a bit of humility into the mix. And it also introduces hope. Maybe there's some new technology. Maybe there's some great idea that someone has for making a big change in your large-scale code base. But they don't have a migration path. You can just say, I don't know how to make a migration path for that. But maybe at some point in the future, we'll be able to figure it out. But until then, we're not going to do it. Right? Now, replacing a piece. Whenever you refactor code, you're taking some piece that existed and you're replacing it with something else. How do we do this? First thing, draw the borders. What is your piece? Is it a function that you're replacing? Is it a component? Is it several components? Is it some combination of components? You got to figure out what the border is around the thing that you're replacing. Once you figure that out, now you can fully and precisely comprehend the semantics of the piece that you are replacing. Using mnemonic methods really helps. Build some kind of a mental model as to what this does. Then you take this piece and you surround it with tests, verifying its existing functionality, verifying your understanding of this code and what it does, what the use cases are. And these are unit tests, integration tests, functional tests. That's something for like scientific communities. And then you implement the replacement and wrap it with the old interface. So all the code which is using the old thing doesn't change. It's just using the new thing wrapped with the old interface. Then you can finally safely and completely adapt the old code to the new interface and remove the old piece. If you get to the end, you're done. It was a success. If you stopped or halted somewhere in the middle, it was a failure. But that's how generally you replace a piece. It's really not rocket science. Thinking ahead. So what kind of code lends itself to 10, 20, 30 plus years of evolution? I'm just curious, like how many in the audience are working with a large code base which they themselves did not develop? Everybody? I should have asked the reverse question. I don't believe you. So, this is only going to increase, right? As the amount of C++ code grows and the amount of core infrastructure this world is living on gets solidified, most software developers are going to be working on large-scale code bases which they did not develop. We've got to get good at this. And we got to write code that's going to be nice to the next person who takes over this code base that you're working with. So what kind of code lends itself to good evolution? Consistent code does. If you have coding standards, consistent naming, consistent documentation, and to the best extent you can, avoid abnormalities, weird things in the code, clever little ideas. These things hurt if you're trying to have a long-term code base. Organized and well-documented code lends itself to large-scale evolution. Stuff that's cataloged. If you use contracts consistently. Code which is readable. So you're writing the code, you know these rules. You write the code for the reader, right? Not for the compiler, not for you. The next person that's going to read your code, that's your audience. Tested code. Code with good unit tests and integration tests and functional tests is a pleasure to refactor. Because you change something, you rerun the unit test, and you figure out what broke. That's extremely helpful. Code which uses the right abstractions. Now this is something that's interesting, because the computer scientist in us wants to make the most generic thing possible. But that may be more generic than what we really want. So you want it to be generic enough to meet all the use cases, but not so generic that it encourages diversity. You don't want to have a million different ways to use your code, if only a few will suffice. It sounds good in a theoretical sense to make it really generic, but in a practical sense with a large-scale code base that you want to evolve over time, you don't want to have diversity of uses. So ask yourself the question, how hard will it be to fix the unforeseen design mistakes which you are making right now? You want the answer to be not too hard. Another important thing to do is to follow the pack. Use industry best practices, standard libraries and tools. We all want to innovate. Innovation is fun. But if you're working with a large-scale code base, what's the value of innovating something? That's a question you got to ask. Let's say you find that indenting 3 characters is somehow vastly superior in some way to indenting 4 characters or 2 characters, whatever happens to be the standard. Is it really worth it for you to go against the entire industry and do something strange? I think not. It's better to just forget about those little things. If you're going to innovate in things that matter for your business use case. So we got to weigh those long-term costs. And collaboration between companies is nice, and that's like what the standardization process is about. If I'm using standard vector, Google's using standard vector, Facebook's using standard vector, we all have vested interest in evolving this to the future in the same way. Whereas if we each have our own little world that's isolated, we're not going to be able to pool our resources. So part 4 of this talk is about an observation, really simple observation. And that is that C++ as a programming language, as a library, has the same properties as a large piece of C++ software. And I'm on the ISO committee, so this is pertinent. C++ has approximately 81,000 lines. That's nothing. Like that's dinky. So it's not extremely large, although it is dense. But there are many diverse dependents of the C++ language and library, right? So evolution's a big deal when you have that many dependents. So it has all the same characteristics of a large code base: successful, widely in use, many past contributors, varying degrees of quality and maintainability, mixed styles, hidden use cases. These always bite us every time we do a release, right? When someone's like, hey, I didn't realize this was an ABI breaking change. And partial refactors. Although I will say partial refactors, generally on the C++ committee, we're pretty good about not allowing something half done into the working paper. That part I think we got down. But the same, I heard future. I stand corrected. I stand corrected. The same pitfalls apply. Assumption, it happens all the time on the committee. Someone assumes that everybody is using C++ the same way that they're using it. Distraction, this is a big deal. It's a large language. There's a lot of things that could be tweaked and fixed. But are we spending our time on the things that are really important? You know, are we spending our time on things like modules, which are really important? Neophilia. There are so many cool things going on with other languages out there. Man, it's so new and cool. Is it really worth it for us to be incorporating these features into C++? We've got to ask ourselves without letting ourselves get carried away with neophilia. And lack of follow-through. Yeah, this one happens, but it doesn't really affect too much. Except that when someone assumes that, oh, this person's working on this other proposal, I'm going to assume that thing's going to get done and I'm going to depend on that one. That can sometimes bite us. So my key questions for the C++ committee are these. And these are bigger things. How can we automate changes? If we change something in the C++ standard, is there a way that we can automatically update all of the users to the new thing? We haven't been doing this, but I think we should. How can we make the standard more approachable? There's only like a handful of people that can understand that crazy language they use in the standard. I think this isn't good. Like, it's good that it's precise, but if it's not accessible, I think that hurts us. What are the easy problems and what are the hard problems? We got to ask ourselves those questions. How do we measure cost? How can we prioritize appropriately? And we've been doing some things to try to help us prioritize better. And what does the complete migration path look like? We don't ask ourselves that very much. And fostering industry collaboration. And this actually does happen. It's great to see companies get together and work jointly on proposals. So, in conclusion, when it comes to working with large code bases, pre-existing large code bases, ugliness and everything in there, I feel like we're really at the beginning. We're not at the end. There's way more that we don't know than what we do know. And I think it's extremely important that we as a community start talking about this and start trying to figure out ways that we can migrate these old code bases. We got to stop pretending like computer science is all about writing a new spiffy API from scratch. It doesn't cut it now, and it's going to cut it even less in the future. So that concludes my talk. I'll take questions now.
Hey David, great talk again. I have two questions for you. All right, are you hearing me? Great. First question is about replacing a module or a component. You say that I should keep an interface at first that's the same as before and then trash it because I can migrate everyone. But what if the old interface makes no sense? Like there are completely bizarre behavior or that I certainly do not want to reproduce in the new one.
So some problems are harder than others. You define that as a very hard problem. I don't know. I don't have like a magic answer to that problem. You have to look at the cases and And maybe the answer is that trying a different approach. But you just got to figure it out. Oh.
Can I just throw in there? Like you were saying that you call the old, you mock the old API, like call the old API. That's just temporary. That's just to see that it's working, and then you can tear it apart.
Yeah, Tony says that you can mock the old API, which is just temporary, and then you can tear it apart. But I think that the question was raised as the old API is so ridiculous that you wouldn't be able to make a new thing and adapt it to the old API. So, yeah.
Okay. Second question. I like that a lot of techniques are like something I can approach on my own on the components I own. But I think the first 2 or 3 slides and first ideas or thing I should start with are company-wide, like deciding for the standards or for the formatting or all that. So would you accept to lend John to my company for a few weeks so that we do that, or how can I do it?
Did you ask me if I could lend John to your company for a few weeks?
Yeah.
Absolutely.
Great. But
once he finishes his book.
Right.
No.
But on my level, if I can take that decision alone.
So you have your realm of influence, right?
Yeah.
And that's just a reality of being a software developer. You can only influence what you have. But what influence you do have, that's your area. And that's where you can do things. If you want to improve things company-wide, you're going to have to get more power or collaborate with other people who have similar ideas and get it done. I think you can make the business case that this is good for the organization in the long term. And that case has to be made and understood by managers. If they're too short-sighted about these things, then, I mean, what's going to happen? You're going to have a code base which becomes unmaintainable at some point. Yeah.
Yeah, I got it. Thank you.
Hey, David, really awesome talk. Is it possible that we can get the slides?
Absolutely. The slides will be put online and will be accessible and there'll be a recording of the talk as well.
Awesome. So, so you touched on like if we have a piece and we want to modify the piece or replace it with a different piece. What if we have hundreds of pieces and they're like spaghetti, like they're tangled with each other, which probably happens in a large code base? How do we proceed? So if you want to replace all that spaghetti with brand new code, but we have partners using that spaghetti code right now, what should we do in the first step, for example?
So when you got spaghetti code, you have to be able to understand it, to be able to work with it. And that's where mnemonic methods really help. It's a hard problem. Like the best I can say is try to use the techniques to the best that you can to apply it. But maybe we don't know yet how to solve a certain level of difficulty in terms of problems. Try something easier first.
Good, thanks.
Yeah.
Thanks. Really great talk, like always, again. But how would you address the counter-argument to reformatting code, which is it breaks Git blame? That's what I keep running into.
Okay. Well, the counter-argument to that is you can put a list of the commits that you did your formatting with, and then Git blame can ignore those particular commits, and then it's almost like it didn't happen. Yeah.
I was curious about kind of the large-scale reformatting, refactoring. How do you deal with that when you have a company that's basically working on multiple branches at one time and they have to be able to merge back and forth between them?
Okay. So you've got multiple branches going on at the same time. So I don't know what kind of version control tool that you guys use. But one thing that works with Git is you can apply the patch to the branch and the master, and then when they come together, they'll be just fine. There's not a real issue there. Like in particular, if you're doing like a clang format everywhere or something like that, if you have a branch, you can apply the clang format on every single commit. You're basically rebasing it, but applying it to every single commit along the way. And then it just kind of works cleanly that way. So that'd be one suggestion I give you.
Hi. Could you give an example of the refactoring that you did using the Python Clang API? Because the last time I looked at using Clang to do refactoring, the AST matchers weren't really there as well in the Python API, and I'm kind of wondering what sort of power you were able to get out of it.
Oh, okay. So the AST matchers, as far as I know, are not in the Python API. So we implemented our own similar kind of thing. It's not that hard. As long as you have access to the AST and you can navigate the nodes, that pretty much gives you the base of what you need to be able to do anything. So if you start with a small refactor and you write software capital, you'll end up with some tools that you can use for bigger refactors later. And eventually you'll have a code base which builds on top of Clang that you can use to do more complex and sophisticated kind of refactors. And it may end up with, you may end up implementing something like that matcher stuff in Python on top of the lower level Python API you get.
Okay, thanks.
And then open source it, as Tony says.
So some of us have code bases which are subject to review by regulatory agencies. And so doing the incremental approach, although it's the sane way to do it, the cost overhead of going to a particular point and then saying, we're going to go to whatever government agency, please validate this so that we can actually, so that we could actually release it, is not really a tenable approach. What would you recommend in terms of having those factors in line with being able to get to an improved code base, shall we say?
Okay, so if I understand it correctly, you have like a library which you're developing and you can't validate it. It's like very expensive and hard to validate it. Is that right?
That would be the effect, yes.
Off the top of my head, I can't think of something that would be particularly helpful there. I don't know how to solve that problem except for politically, you know, to try to get at, oh, I see hands coming up, so I want to let the experts answer.
Well, this happens at Bloomberg all the time. And so what we have to do is we have to batch up our changes and then it has to be evaluated. But you do have to have it evaluated, so you simply do the refactoring and the forward moving at the same time. That's it.
Right, so you have to hold it off to the side.
You would do them at the same, you're going to have it evaluated. So you're going to do the refactoring evaluation and the forward moving evaluation at the same time. That's it.
So John is saying that we do the refactoring evaluation and the forward moving evaluation at the same time and kind of like get these things done in parallel.
Right. You have to follow the regulatory time frame.
Yeah.
Just you come to that.
Okay, a comment, you were talking about large code bases. What you said, the wisdom in the beginnings is not new, and it applies also for small code bases, like broken window effect. I'm not sure if you didn't use that term, but that was in the pragmatic programmer, the broken windows effect, and exactly that happens if you have small negligences, or you end up with your garage.
Yep, absolutely.
And for those who are not aware of that book, get it, appreciate it. If you're new to test automation and stuff like that, get the pragmatic starter kit and appreciate it. Even if you're just doing small stuff.
Thanks.
So on the previous point, I was going to add to that I think the meta problem there is you have some external force which is making the cost of iteration high. And that might be a government regulatory body, it might be a platform regulation thing, it might be that your code is on millions of machines all across the world and you have to find a way to update them, and not everyone wants to patch every day. So, you know, that's a kind of a meta problem in building capital, I guess. Would you say anything about that? I mean,
I agree.
All right.
All right, well, if there's no more comments, then we're done.